So last class we were been discussing, so I'll give you a brush up of the last class what we were actually discussing on, right? So first thing what we discussed was the algorithm template. Okay, so any program or algorithm you write, you should follow some basic format. That is, one is you have to name your algorithm. That will help you to identify what type of algorithm you are using, so that if anybody wants to refer to your algorithm, they can do it. Okay, and input and output. So those who are writing the algorithm should be knowing what is the input you need and what should be the expected output. So that should be needed. And context. So context tells you about the technical part of an algorithm, right? So we saw an example of like adding two numbers. So the context is finding the sum of two numbers. That shows the context. And solution. So where should your solution be uh, saved? Should be displayed to the user. All that is your solution. And analysis. So anybody ask you to explain your algorithm, you should be in a position to explain how each steps come and what is the relevance of writing a particular step. So that is your analysis. There should be self-analysis done for your algorithm and why you need a particular step and why not a particular step. That should be proved or explained when asked. That is the analysis part. Okay, then we also saw about the building blocks of the algorithm. So there are three main building blocks. One is sequence, selection, and iteration. Okay, so sequence is sequential format, selection is wherever the if statement comes, and iteration or repetition is like either it's a for loop or a while loop. So all these are called as a iteration. Okay, so these are the main. So any algorithm you write should fall into these three categories or building blocks. Okay, so either it should be sequential or it should be selection one or iteration. So we saw selection means like using a if statement. So if a condition is true, go this way, if not, go this way, and finally what is your output. Okay, so we saw an example of finding the greatest of two numbers. And repetition is like uh, 1 minute. Somebody. Okay. Right. So repetition is like you write a statement and how many times you want to execute it. So there will be some two or three lines of statements or sometimes single line statements. So till what you have to execute that. So that is a repetition or it's called as a looping. So all the while loop and for loop, all that comes. So it will be satisfying till a particular condition is true. Okay, so it is a repetition. And we saw about also how you can express an algorithm. So expressing an algorithm will be in the form of pseudocode, flowchart, programming language, and we saw a little bit of the pseudocode, right? So what is pseudocode? It's a kind of pseudo means false, right? Code means it's an instruction. So it is not nowhere you will be using a technical or a technical language or a programming language while writing the algorithm. It will be just English sentences in a way that everybody can understand. Okay, what is a step should be followed next. So pseudocode is another programming analysis tool that is used for planning a program. So the non-technical persons or non-programmers usually explains a algorithm to the other person using a pseudocode. Okay, so there's also will have the three different types of logical structure, that is sequential, selection, and iteration, right? And this is an example of pseudocode. So sequential is step-by-step execution. So you will start, you will read, they will compute, and then print, and then stop. So this is your sequence logic. Selection is using a if statement. So read A and B. If A greater than B, then print else, print this, and end if. Okay, end the if statement, and then finally stop. Okay, so there are some languages actually is like pseudocode, they say it is a script writing for Linux. Okay, so Linux, some of the programming language, that is scripting language, even today they will follow something like pseudocode. But the problem is like, so you keep your, uh, that is, if you keep your scripting or a program very simple as this, okay, so what will happen is there will be your compiler, what you're using will find a difficulty in compiling. Okay, so see what happens is when you do a lab, okay, so you as a student will be very interested in seeing the output. One program you write, you run, and immediately we need the output. So if the compiler tells you there is a mistake in so and so line number, we actually feel irritated because we have to go back, check what we have left, and there are always a chances that you would have left a semicolon or a hash or a ampersand symbol or something, right? So the compiler in C is very strict, and there are a lot of unwanted symbols also there, right? But if you use a language like this pseudocode, it is somewhere related to a simple English sentence. So what will happen is the compiler will find difficulty in identifying the mistake. But for efficient programming language, the compiler should be very strict. Okay, so the compiler should not leave out any mistakes, and it should be able to find out each and every mistake. So that is why this Linux scripting language, etc., what will happen is like your program itself will look like this, and because of that, it will not be very successful programming language because of the failure of compiler to find some mistakes. So it will still run, but you will not get your expected output. Okay, so see, so and so program is very small. It will have only four lines. Okay, you write enter two numbers. Even in this, if you enter two numbers which is equal, your answer you will never get it as equal, right? Because A is big, B is big, that's it. So like this, there will be a problem with the output when the compiler is not able to find a mistake. So that is why the pseudocode are not much used for programming language. Uh, and if there is a programming language with pseudocodes again, it will be a little difficult for the program to run. And repetition in pseudocode, you use this word, okay? Start, initialize, while, print, end while, and stop. Okay. And next type of representing the algorithm is in the form of flowchart. So flowchart we always use in our daily life, right? So if you want to like especially the experimental procedures, if you want to execute some experimental procedure or even a cooking recipe, we always use a flowchart to write because it is very easy for us to find out which is the parallel events which is going to happen, which is a sequential event which is going to happen. So flowchart will give a clear picture of, see if you are using many if statement in a program or a while statement. So this flowcharts will give a very good description of like how the program flows. So it will give a very good clarity. Okay, but technically when you write the flow chart, yes, you have to follow some symbols. Okay, so this will demonstrate the way code is organized, visualize the execution of the code within the program, show the structure. Okay, understand how users navigate a website or a program. Okay, so it will be like, right? So it will be a very clear picture. It will give you like how the program flows. Okay, so that is the use of this flow chart. And maybe you would have come through the symbols, or even if it is new, that's okay. So this oval shape, right? So that is two parallel lines with the curved endings. So this is a symbol for a start and stop. So this will denote where is the starting point and ending point of the program. So this is a oval shaped shape, and this is a flow line. Okay, flow line can be in any direction, top to bottom or right to left, left to right. Okay, so these are flow lines which will denote the direction of the logical flow in a particular program. And parallelogram is usually used for input and output operation. So what is your input? So what is the integer you're going to get? What is the input you're going to get from the user? It may be a string, it may be a integer or whatever it is. So you use the parallelogram for giving up that, showing that this is the input step. So what is the variable you want? And output. So print statements. Okay. So print statements like print A or B, you have to use the parallelogram for it. And rectangle is for the mainly process. Okay, so process in the sense like you have a arithmetic operator there. It is addition operator or it's a multiplication operator. So all that will come inside your rectangle. So that is a process of the entire program. So that has to be denoted in your rectangle. So diamond shape is mainly used for if statement, if else statement, and if then statement, mainly for if. Okay, so I repeat the symbols. So oval shape is for start and stop. Flow lines will show where the flow of a program will happen. Parallelogram is for input and output, that is mainly your print statements will be enclosed in a parallelogram. Rectangle is for process identification, that is mainly it is for either arithmetic operation or any operations you want, you will be using a rectangle there. And diamond is mainly for if statements. Okay, so if else, if then statement, everything will be using the diamond shape. Again, flowchart. Okay, any algorithm you write, it should fit into these three. That is, it should be sequential, or it should be selection, or it is repetition. Okay, so even flowchart, you will have to follow this. So this is an example of a sequential logic. Okay, so this is again the same example of adding two numbers. So this is the input, and here the algorithm name is given. Okay, this is start. Either you can use the word as start or begin. So both are right. And what is the algorithm name? Add two numbers. Okay. So next is the, what is a symbol? This is a parallelogram, right? So input is your the simple input is for the parallelogram. So first step, we are getting the first number. So when you have to add the two numbers, you want the input for two numbers. So the first parallelogram is for the first number, and second parallelogram is for the second number. So now the input is done, right? So you have used parallelogram here. And next is your rectangle, where the process, that is you want to find the sum total of the number. So total equal to first number plus second number. Okay, and again you have a parallelogram, and which will display or print the two numbers. And finally end statement. So your algorithm of the adding two numbers are entered here, so that is why they have used the name again here. So this is like a simple language they have used. Sometimes you can even use the technical terms here, like int a, int b. Okay, c is equal to a plus b, print c, end or stop. That is also right. Okay, so you can use simple as this, or you can even use the technical part in writing the flowchart. Okay, but for you actually it is only a brief of what flowchart is and all, and you have to explain about this. But when you actually write or you try to draw a flowchart, what they do is they put two parallel lines here, and so that all your symbols are equal sizes. Okay, and these two lines should be equal, and you put a curve. And again, so they actually draw it very meticulously with the same length. Okay, and because as a rough diagram we always have a habit of casually drawing it, but actually this is an art of drawing. So if you see, all the endings will be in same. So when you technically draw a flowchart, better put two parallel lines, so that all the size of the boxes will be almost similar, and it has to fit into these two parallel lines. And the sizes of these two or these three parallelograms, everything should be equal, so that care should be taken. Okay, now we go to the selection. Selection is like when we use a if statement. Okay, so this is again an example of finding the greatest of two number. First is start. Okay, so here this curve is not proper, but it is a curve line at the both the ends. Okay, so start. What is your input? Okay, if A is greater than B, okay, then what it should do? Print A. If not, print B. Okay, so if you want one more if statement, okay, also you can include in this. Okay. So it can be either your if statement can be either in the two ways or it may be a multiple selection way also. Like if you have more if statement also, there will be a provision for drawing a line here and then taking into two different conditions. Okay, so if statement need not be so here even in finding the greatest of two number, you can even have like one more section where the numbers are equal also. Right? So that can be done. Right now, is it clear? Somebody has messaged that voice is breaking. Sometimes it happens. I don't know for what it will happen. Okay, so what I was talking is about the if statement. So if statement, you have to draw this diamond symbol for the flow chart, and you can write your condition here. And S, where does it go? No, where it does it go? You have to specify it. And repetition is like going for a repetitive function. So you can see here a new symbol is being introduced. So this is especially for and while loops. So it looks like a elongated hexagon, right? So start input. Okay. So this is like finding the factorial of a number. So they put the assume that a fact equal to one, and then if for I is equal to one, so you repeat the for loop till n. Okay. So if the loop is repeated, you can see here the symbol what they have used. Okay. So till the condition is true, this loop will be executed. If not, so if this condition is not true, then it will go and print the factorial. So what is factorial? 1. Right? So if you enter your n as 1, what will happen? If you enter n equal to 1, that is, they have asked you to input n. So if you enter n equal to 1, then it will come to this fact equal to 1, I is equal to, the condition will be no, so it will print as 1. So the factorial of 1 is 1. If it is greater than 1, what will it happen is, so for I is equal to 1 to n, right? So this loop will get executed till the condition is true. So first it will take 1 and then into I. So now your I value will be changed. It will give a increment to 2. So now your fact will be 1 into 2. Then it will come back here. When it comes back here, then the condition is false. It will print 2 as your answer for the factorial for 2. So likewise, you can put any number and you can see that the loop will be repeated till the end what they have entered. So if the n is something big like 15 or 16, so the loop will be executed till your condition goes to the 15th number. Okay, and it will print the factorial of it. So there are some more examples of how they use the if statement and the looping statements. So there's a condition true, and then the loop will be executed here. Okay, so here it is false, right? If the condition is false, here a loop is executed. So what does it tell us? If the condition is true and if there is a loop, it is called as a pre-test loop. Okay, and you can see here the process is below the condition. Okay, so some condition you give randomly. If the condition is true, then the process will be executed. And once the process is executed, you want to execute the loop till the condition is false. Okay, so once the condition is false, it will come out of the loop. So this type of looping is called as pre-test loop. False test loop means, let us post test loop means, say if the condition is false, it will go back to the loop and then your process is executed. Okay, so first itself a process will be executed, then it will come here. If the condition is false, go back to the process. So this kind of loop is called post test. This is just for your information. So what you have to learn is like flow charts, what are the different symbols what they use, and what are the different types of algorithm. That is, it may be either sequential. So write one example for sequential algorithm. Okay, if it is selection, write one example using the flowchart, and if it is iteration, write any example what you do using a flowchart. Okay, so that's all is with respect to writing the algorithm. So algorithm, how you can represent, you can express the algorithm in three ways: pseudocode, flowchart, and the next one is programming language. So next what you are going to see is a programming language. Okay, so pseudocode also three. What are the three types? Sequential, selection, and iteration. Only thing is your pseudocode will look like an English language, and there is no technical symbols used into pseudocode. Whereas in flowchart, you use the symbols, right? And there are three types again: sequential, selection, and repetition. And next we'll go to representing the algorithm using a programming language. So how do you represent an algorithm using a programming language? So algorithm describe the solution to a problem in terms of the data needed to represent the problem, right? So now like how you use the programming language to represent the algorithm. So algorithm is always a solution to a particular problem, right? So when somebody give you a problem, so problem is nothing but the people will come and ask you like, please develop a program for say, okay, I want to find the grade of your class. Okay, so they ask, okay, he'll be a non-technical person who will come and ask you like, okay, I need to find the grade of your class. So what I do is first is sum total all your internal and external marks, find the total, take the average, and then what you do? According to your CGPA calculation or something, they then calculate your CGPA and then they'll put the grades accordingly. Right? So this is a way how a person will ask. So the problem given to you is finding the grade. So this is how that is what is being given as a problem here. Okay, so problem means some X person comes to a person and asks, please solve this issue. Okay, so that is a problem given to you. So here in this case, the example what I spoke about is finding the grade in a particular class. So if a person comes and asks you, please find the grade of a particular class. So you should be able to describe in a programming language or in an algorithm that how you're going to find the grade. So there will be some sequential step, right? So first input the marks. Second is add the marks, total it, and there will be a calculation for your CGPA calculation. Okay, so take divided by some numbers, and if it is and you put the grade according to the total what you're going to get. It may be A plus, S, or B, or C, whatever it is. Right. So this is how you help the society. So somebody comes with a problem, you have to solve it with the help of a program or an algorithm. So programming language must provide a notational way to represent both the process and the data. Okay, and to this end, languages provide control constructs and data type. So don't get confused. So representation of an algorithm using a programming language is nothing but using a program for to solve the issue. Okay, this is nothing other than writing a program. So so sometimes like they call the program as an algorithm also. So the last method what you are learning is, whereas pseudocode is kind of a casual algorithm what you write, flowchart is actually symbols. It will give you a clear picture like what is executed first and what is executed at last, whereas representing in a programming language is like directly writing a program, okay, without the algorithm. So this is like advanced people will be going directly into the program. So programming is a process of taking an algorithm and encoding it to a notation, a programming language, so that it can be executed by a computer. So you very well know that a computer will respond to a zeros and ones, right? It will respond to zeros and ones. So what we do is like we write a program, right, in a user friendly way or a user however we can understand we will be writing. So that will be decoded into zeros and ones and sent to the code part of the computer so that it will execute the program and give you again in the forms of zeros and ones, and then we again decode in the form of however we want. Right? So programming is a process of this coding and decoding. So you are if you want to make the machine understand your program, you have to encode into the machine understandable language. Machine understandable languages are only zeros and ones. So you write a program, you give it to the computer, and it is going to convert into zeros and ones, and then it will execute the program. It will get you back what is the output of it, and then what you do, you have to read the output, right? If it is of completely zeros and ones, we cannot read what is the output is, so we will again decode it into whatever language we want. So that is the work of the program. So it is like a bridge between the computer and the person. Okay, so actually it is fun with respect to coding. If you enjoy it, actually will be like you can uh, do many things with the program. Okay, so although many programming languages, so there are a lot of programming language that is coming, and today they will use one syntax, and after 6 months you see they would have gone to the next version, right? And the syntaxes would may be different or may not be different. So these things are happening every day in the computer science or the CSIT departments. So what they do is like they keep updating even our apps, right? So we have any app, you can see a routine update happening in the apps, right? So either it's maybe a WhatsApp or it may be any app. What will happen is after few, maybe 2 or 3 months, it will ask for your update. So when it is asking an update, what is happening? The current version is being upgraded to a new version. So when it is upgraded to a newer version, so what will happen? So some additional features would have got included to the existing version. Even our Android phones or whatever Windows we are using the software, routine updation is happening because every day new programming, new features, and new things are coming up. Okay? So same thing is a need of the programming language also. It will act as a bridge between the machine and the human. Okay, and without an algorithm there cannot be no program. It is better first you write stuff down algorithm and then you will go directly to a program, right? And this will act as a bridge between the system and the humans. Okay, so there are three different types of language, right? So low level language, middle level language, and then it is a high level language. Okay, so whatever programming language what we are learning nowadays belong to high level language. Even C, C++, Java, basic language, Fortran, these are all outdated now. Okay? So all these are belongs to high level language. Low level language is just machine understandable language. It is only zeros and ones, right? And level language is like partially machine understandable and partially to high level language. So the example is like it's called as assembly language. I don't know whether you are aware of it, right? So it will be a kind of mixture of both middle language, but this is hardly used any type, this level language. Okay, so whatever the numerical calculations, what you would have done in maths, that is binary conversion of a number, right? Or from binary to number. So all this started with the in the era where the computers was introduced. Okay, so how to convert a number to a binary number? From binary, how do you convert to a number? Right? So all that is the low level languages, but we hardly use it anywhere. Okay, because whatever programming languages now we are using is a high level language. So these two languages they used only when the computer was invented at the first time. So those time they never had some languages. Slowly these people came into picture. Right? Before that they were using low level and middle level language. So these are the three types of language. Now your algorithm should fit into any of the three languages, and these both you can scrap it off because we are no longer using it. We are only refining to high level language. So representing the program by an algorithm should be like high level language, and before executing or before typing a program or feeding a program to a computer, it is always better that you analyze the program yourself and see whether it will work, right? So low level language is a machine understandable language. So whatever we have discussed, so it will be the binary numbers, zeros and one. It can be understood only by computer, not by us, because if you would have seen the binary conversions in the mathematics, one like three-digit number will have a lot of binary numbers. So in such cases, if you are using that for programming languages, it will be too difficult for us, and you miss out 1 0 or 1 1 in that. Yes, your program is gone again. So that is why we have never used, only at this beginning stage where the computer started off, they use this low level language. Other than that, we have never touched on it. Okay. Uh, Middle level language, right? So it is kind of an intermediate language. So this will be a bridge between the hardware and the programming layer of the computer system. Okay. So to should give you a clear picture, right? I'm not able to include. Can you see my board? I don't think you can see it. Maybe. Okay, I'll give you the picture like how they define or they separate out uh, the layers of a computer. So first, the core layer will be what you call as a machine understandable language. So that is called as a heart of a computer system. So the core level will be only zeros and ones, and then comes a middle level language, which is kind of a bridge. So it is a partial programming language. It's not a, and this also is not being used much, right? So this serves as a bridge between the raw hardware and the programming layer of a computer system. And medium level language is also known as the intermediate programming language and pseudo language, kind of sentences like language. And C intermediate. This is not a C what you're using now. Okay, and Java, bytecode are some examples of. So this is when they started with the programming language, they were called as C intermediate language. So this is not at all C what you are using now. What we are using now is always a high level language. Okay, so they started the programming language using the middle level, and again the problem happened because this is not a very core programming language, and what will happen is a compiler will have a difficulty in finding out the mistakes. There was no compiler actually during using the middle level. So if your program is not checked and if you are executing a program with the mistake, then it will lead to a lot of confusions. Okay, so that is why this was again not successful at all, and it was very that this also started at a very long back, and just for maybe a 2 to 3 years alone, they have used this middle level language and they were fed up of this language. And then they started with this high level language. So everyone knows what you're writing. So that is high level language is totally human understandable, right? So when you give a print statement, you know it is going to print. If you give a read statement, you know for what it is. And if you're writing C is equal to A plus B, you know for what you're writing them. Right? It is completely human understandable one, and they use this coding and decoding here. So your language is decoded as zeros and ones to the machine, and the machine will complete the task, give you the output in zeros and ones, and that will be again encoded to the human understandable language. So this is for our uh, understanding and it is for our convenience. We adopted this high level. Until today, we are in this high level language. And last till the last decade, these were all famous. C++ and Java, all these were famous. And now, like people are trying to simplify this high level language. That is why they have come across this Python. It is how they are introduced. So last 10 years, more than 10 years actually, we are much dependent on Python for everything, starting from website construction and for even for your robotics or artificial intelligence or machine learning, whatever we talk today, everything, everybody follows now Python programming because it is easily understandable by us, right? And you need not have a core, you need not be a core computer specialized to learn that language. It is flexible for anyone. Actually, learning Python requires hardly 15 to 20 days. If you put your effort, it's just 15 to 20 days continuously to get well versed with Python. Okay, so nowadays whoever is in IT jobs or any sector, so if you write that you know Python programming, it is very very impressive. Okay, so that is why like people go to this high level language because it is much easier, right? And you can write your own language, own programs. You need not depend upon anybody. Once you understand, okay, print statement is for this, read is for this. Yes, I can go ahead with writing my own program. Right? So that is why we have come and we are sticking on to this high level language. Okay, so algorithm for problem solving, right? So this maybe I'll start tomorrow, right? Because I don't want to overdose you with everything in the beginning itself. So slowly we'll go through. So if you have any doubts in today's portion, you can just unmute and you can ask me. So it is open for discussion now. Any doubts? Students, I don't know whether you are aware of online courses, right? Because there are a lot of people who are offering online courses. Like one is NPTEL, okay? The other one is MOOCs, one is Coursera. These three is what I know. There may be other online courses offering people also. You see to it whether you can. So you can just see to it that whether you can take at least one online course per semester, anything of your choice. Because if I take this class, you will have diverse interest. Okay, one may be interested in multi subjects, one might would have interested in programming subject, whatever it is, or interdisciplinary. You want to study something interdisciplinary, but and you can still do it. Okay, any courses you can take in those online platforms, maybe you're aware of it, and try to do one per semester. Like Coursera is being given by foreign university, mainly even Hopkins University and all this. They will be giving, and NPTEL is by IITs and IIScs. Mainly Indian universities are also there, foreign universities are also there. So if you need a certificate, they charge you very nominally. That is now If you need a course certificate at the final, you have to write an exam, and they'll be giving you a certificate with grade. So you have to pay around 1,000 rupees for it. Okay, and there will be routine assignments. There are 4 week courses, there are 8 week courses, there are 12-week courses also. So you can take according to your flexibility and try taking at least one. This will give you a lot of value later because those certificates are directly from IITs and IISs. Okay, so you can look. So if you want any extra, so it is not, there is no boundary for learning, right? Even we do, we as a faculties, we choose, we try to manage at least one NPTEL course per semester. So you can take anything. You can even learn some subjects from mechanical engineering if you are interested. Anything. There is no preliminary knowledge or anything you want, right? So you can choose any, and they teach you from the basic. Yeah, but you have to be cautious in submitting your assignments on time. Just as MVIT staffs will give you more time for submission, they don't give. If it's 11, if it's a particular day, 11:59, the portal is closed and you cannot submit assignments later. So you have to be very punctual in submitting the assignments. And if you carry a certificate that if you are 90 plus or 90 or 95 plus, you they'll be giving you a gold medal certificate, and if it is some range it is like silver. So they give a tag along with your certificate also, whether you are a gold medalist or you're silver. So it will carry you a weightage and you can put in your resume, and it is very very impressive for any recruiters. Okay, so from third semester try. Even your seniors, they even try taking even 2 or 3 subjects per semester, and I think it will carry some credit to you also. I am not sure of that. You can inquire with anybody that if you do some course, there is some credits that is added to your final marks also. Okay. So, anything else? You can just ask me. Any doubts? Okay, so if you don't have any doubts, what you can do is now, uh, you have a notebook. You take a notebook, and what we discussed today is mainly a flow chart. Okay, draw a flow chart of anything of your choice. Okay, it can be greater than like two numbers, which is like finding the greatest of two numbers, or you can find even the greatest of three numbers. You can just draw a flow chart. Okay, or it can be addition of two numbers or subtraction of two numbers, whatever it is. You draw a flow chart and try to write what you interpret from the flow chart. Okay, in the terms of programming language. Say now you are aware of C, right? You can write it in C itself. Okay, so that it will keep you awake from sleeping. Because I really don't know what you people will be doing.